and reading from files, reading and writing to files. So in the last lecture, we saw fgetC. So fgetC reads one character from a file stream and returns the result as an int value. Right? And we had this little program here that read in this file temp.txt one character at a time. Right? So down here we've got a little loop. It's a little while loop. So we call fgetC, store the character in C, right? And check is C, if C is not equal to this constant EOF. So EOF is defined in standard IO.h. So if it's not equal to EOF, which is end of file, then we know that we read in something successfully, and we can just print the character using putchar. So that just reads a file and then echoes the contents of the file one character at a time. Yeah, question? Yeah, so he reads a character, moves to the next character, reads a character, goes to the next character, and so on and so on. That's right. And then we saw fgets. So fgets reads, at most, count -1 characters from that stream, or from this file, and stores the characters in the string pointed at to by that pointer. Right? It returns a pointer. It returns the pointer str if it succeeds, or it returns a null pointer on failure. So if you read to the end of the file, then the next call to fgets will return a null pointer. Right? And so we had this little program here that just reads, using fgets, a file one line at a time. So we call fgets with the value 100. So remember, this 100 is read at most 100 minus 1 characters into the string pointed at by buff, right? And buff can hold a string of length 99, right? Because you need one character for the null terminator. So this is perfect, right? We can read up to 99 characters into there, right? Add the null terminator, and we are guaranteed that buff is always a valid string, right? And it reads it from the file f, right? Which we opened up here. Right, so this reads in a file one line at a time, and then prints each string to standard output. Now this assumes that each string, each line, sorry, is less than 99 characters or less in length. Right, if a line is longer than 99 characters in length, then what ends up happening is it reads in the 99 characters of the string, prints the 99 characters of the string, and then it reads in the next call to fgets will read in the next 99 characters, and so on and so forth. Okay, so there's fgets, right? So notice it takes in a pointer to a file, right, and then a pointer to a string in which to store the line, and it also takes in the number of characters in which to read, right? The maximum number of characters to read. And so that's good, right? This is safe as long as your count, right, is smaller than the size of the array for that str points at. Right? Now, if you Google online the question, how do I read text from the console in C? Right? And then a lot of the time you'll see, well, you can just use gets. Right? Now notice gets, the only difference from fgets is one letter, right? Fgets versus gets. But the parameter lists are very different. Right? Fgets takes in a file, a string in which to write, and the maximum number of characters in which to write. Gets does not take in the maximum number of characters to read, right, or to write into str. Right? So gets reads standard input. Right? It reads everything in standard input up to the new line character, and then tries to store all of that into the string str. But it doesn't resize str at all for you. Right? So if your line is longer than the array that str points at, you're going to have a bad time. Right? So this reads standard in until into the character array pointed at by str until a new line character is found or end of file occurs. Right? So this is super useful if you're writing up a little program and you want to prompt the user to type in something, and you're not going to use this program for anything important. Right? So you want to test something out, right? You type in some input, press enter, and then your program does something. Right? So gets is perfectly appropriate for that. right? But you should never use gets in production code, right? So gets is notoriously insecure because it does not limit the amount of characters read, right? So it's fine for little toy programs that you would write, often in an academic environment, unfortunately, right? Totally inappropriate for production code. And in fact, it's actually been deprecated after C99, right? Deprecated means you should no longer use this feature anymore, right? And it may be removed in a future release, right? So let's look at the little program that uses gets, right? So this is the typical of a type of program that you would write using gets, right? You ask the user to type in some text and press enter, right? I'm going to make a little array of length 10 in which to store the text. Now I'm going to use gets, right? And that's going to read standard input until it sees the new line character and store the contents into str, right? Notice I have another array, right, declared immediately after str. Right? So I have another array of length 10, and I'm not using that in gets, right? I'm asking gets to write into str, right? But I'm going to print both str and unused every time. All right, so let's see what happens when we run this little program. Okay, so this is read keyboard. Okay. Right, so enter some text and press enter. Now remember my buffer, my string str, I can type in a string of at most length, safely I can type in a string of at most length 9. Right? So 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? So that string has length 9, right? Plus the null terminator, which is 10. So that string fits safely into my string str. So if I press enter, it says you wrote 0, 1, 2, 3, 4, 5, 6, 7, 8, right? And then there's nothing in the unused string. Run it again, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's one longer than my buffer can actually hold, right? Than the string can actually hold. So if I run that, it still runs, right? Still prints the right output, right? So that really is the string that I typed in. But I know for a fact that there's a null terminator sitting in this string here, right? And so somehow this still printed the right output. Okay, so that's, which is unexpected, right? So let's try something a little longer. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay, so that one definitely does not fit into the buffer, right? That's 11 characters long, right? Right? 0, yes, 11 characters long. Right, plus the null terminator, so there's actually 12. So now, when I print out the original string, it prints out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, right? And then it says there's actually a 0 in your other buffer, right? So I'm writing the string str, and I'm writing the other buffer. So what's happening here is what's called a buffer overrun. So I have my string str, right? And then it turns out what happens is right after it I have unused. Unused. Okay, so when I run gets, when I run the program and I type in the number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. So there's my 9 characters, right? 10 is 10, so that's the length of my buffer, right? 9, and now there's another 0. So the 0 gets written into unused, and then the null terminator gets written in, right? And so when you print str, right? The way the print function works is it looks at all the characters in str until it finds the null terminator. So you get all 10 characters of str, and then it keeps on going. So then you get the 0, and then you get the null terminator, which is why you get this output here. Right? That string is longer than length 9, which is what str can hold. Sorry, that's what you get here. Right? And then when you print unused, well, unused now has this 0 followed by the null terminator in it. So that's why you get the 0. Right? So you can actually write into another variable using gets. Where'd the lecture go? Right? And that's called a buffer overrun. Right? I've overrun the limits of my original buffer and written somewhere else. Right? And this is one of the features of gets. Right? Gets doesn't actually ask you for the maximum number of characters to read. Right? It just keeps on going until it sees the new line character. Right? And so if the input is longer than can be stored in your buffer, right, it keeps writing past the end of the buffer. And it turns out gets was used in a lot of old C code. Right? Some of that code is actually exposed to users. So a malicious user can intentionally overwrite a buffer and get access to or write into memory they shouldn't be able to, which is exactly how this thing here called the Morris worm works, or worked. The Morris worm. So you don't hear much about these things anymore. So a worm is a kind of computer malware. Right? So a computer worm is basically a program that tries to replicate itself. Right? So it's a program that copies itself and then sends that copy out onto the internet or onto the network, right? And tries to copy itself onto other computers. Right? And then so it gets onto another computer, it tries to copy itself, and it tries to go to another computer. Right? And so on, and so on, and so on, and so on. Right? I guess most worms now are malicious, so they actually try to do something when they infect a computer. Right? So they don't just try to spread, they actually try to do something to your computer. Right? They might encrypt your hard drive and then send you a nasty message saying, hey, pay me 500 Bitcoin to unlock your computer, right? Or something like that. Right? One of the first worms that was written, it was actually the second one, is called the Morris worm. And the Morris worm was written by a grad student at Columbia, I think. What university? No, wait, it begins with a C, hang on. Computer worm, Morris worm, where is it? I had the web page up just a second ago. It's a little bit of a funny story. So it's the first worm that caused a bunch of problems on the early internet. Okay, so the student was a grad student at Cornell. He went over to MIT and launched the worm from an MIT computer to try to hide his tracks. This worm used gets. So it exploited a hole in gets. It exploited a hole in a program called FingerD, which is a common program on most Unix computers. Right? The old implementation of that uses gets. Right? Since gets doesn't have a bound on its input, it's possible to overflow the buffer without an error message. Right? Normally, when this happens, you trash the stack frame and your computer crashes. However, if you know where everything is on the stack, as is the case with a distributed binary like BST, you can put selected values back into the return stack frame. So in other words, if you actually know how your operating system is implemented, which you do in Linux because all the source code is open source, right? Or in BSD, which was a variation of Unix back in the day. It still is. Then you can actually intentionally use this buffer overrun to write into memory that you shouldn't be writing into. And then you can end up taking control. In this case, the worm can take control or is able to find a mechanism to replicate itself on the host computer. Okay, so if you're in the security program, I think you will at some point end up writing your own buffer overrun exploits in some course. Right. All right, so instead of using gets, don't use gets in production code, use fgets instead. Right? Fgets is relatively safe because you always specify the maximum number of characters to read in fgets. Right? Alternatively, you can use getC or fgetC to read one character at a time. Right? Okay, what does this one do? Oh, this is fgets. Okay, so here's the same program written safely, right? So this is written using fgets, right? So I'm going to prompt the user for some text, right? Here I have a buffer of length 10. So when I call fgets, I'm going to pass in 10. Fgets won't read in more than 9 characters, right? And so now when you print this out, right, I'm going to print out the contents of str. Where to go? Right. Well, print you puts you wrote right here. So I'm going to use printf to write str. But notice that I have a little loop here, right? And the reason I have this loop is because if somebody typed in something longer than length 9, right, I actually want to process all that information. But the only way to process that information is to call fgets again, right? Now, how do I know that I've gotten to the end of their input? Right? So we told them to enter some text and pressed enter. So I know their input ends with the new line character. Right? So what this loop does is it constantly calls fgets, and it looks for the new line character at the end of str. Right? When it sees the new line character at the end of str, it knows that that's the end of the input. Right? So when you run this little program here, this is read keyboard 2. Right? So now I can type in a whole bunch of stuff. Right? Now my buffer is only length 10, but that's fine because I'm only going to read in 9 characters at a time. Right? And so now it prints out the first 9 characters, followed by the next 9, followed by the next 9, right? Until you get to the end. Right? And so that's the way you handle that's the way you can handle arbitrarily long user input. Right? You just write a little loop that loops until you end up seeing the new line character in the string. All right, so that reads in, get C reads in a character, fgets will read in a string. What if you want to read in numeric input, right? So, or some other formatted input, right? So to read formatted input, one way to do it is to use fget, so read in a whole line of string, a whole line as a string, right? And then parse the string, right? So we saw strtok as one way of splitting a string at tokens. There's another function called scanf that you can use to parse a string as to parse a formatted string, right? This is probably the way you should do this, right? Because fgets, that's your input function, so that will read part of the file stream. If there's any errors, fgets will tell you about that, right? So in other words, you leave the error handling to fgets, all the input-output error handling to fgets. If there's any errors on the actual stuff that was read, you can use scanf to figure that out, right? So it splits the reading errors and the parsing errors separately, right? Alternatively, you can use this function called fscanf. So fscanf will read formatted input. And the problem with this is it mixes the I/O and parsing error handling, right? So in other words, if there's an input-output error, or there's an input error, right? So there's an error reading the file, you have to deal with that from fscanf. If you try to read in something like a number and it's not a number, you also have to deal with that in fscanf. Right? So fscanf reads formatted input. Right? So it reads that file for some stuff that's specified by this format string. Right? So this format string is similar to the format string from printf. Right? So %d will read in an integer. Right? %f will read in a floating point number, %s will read in a string, and so on and so forth. Right? So it's going to try to read your file, right? Interpreting the contents that it reads according to this format string, and then it's going to store the results in whatever variables are sitting after this comma. So that's what the ... means. Right? It returns the number of things that were successfully converted. So I'll explain what that means in just a second. So, oh, wait, sorry. I need a demo program here to show you what's going on. Fscanf demo. Okay. So okay. So we're going to open up this little file called simple.txt. Right? So we're going to open it up for reading. Right? So simple.txt, it's got an integer value, then a new line, then a double value, then a new line, and then a string. Right? So int, double, string. So I want to read in an int, I want to read in a double, and I want to read in a string. Right? And so obviously I need somewhere to store those values. Right? So I have a variable of type int, variable of type double, and a string. Right? Okay, so my file is open. So I can use fscanf to read in the integer value. Right? So I ask fscanf to read in from the file f one integer value. Right? So %d. Right? So this will try to read the file for an int, and it'll store the int in the variable point, in val1 in this case. Right? You pass it a pointer to the object where you want to store the result. Right? So I'm expecting an int, so I'm going to pass a pointer to an int, which is val1. Right? So fscanf will write into val1 the integer that's sitting in the file. Right? The way most of these conversions work is that it consumes any white space in front of the value first. Right? So if there's a bunch of spaces before the integer, it'll eat up all the spaces and then read the integer. Right? And then it stops immediately one character after it finishes reading the integer. Right? So it leaves everything else in the file. After I read in the integer, I can read in the double value. Right? So, n is the number of successful conversions. So if I read in the int successfully, n should be 1. Right? Because there's only one conversion here. So on the next down here, I'm going to use fscanf to read in one double value. Right? So %lf. L is long, f is float. So that's a double. Right? I want to store that value in val2, so I pass in a pointer to val2, right? Or the address of val2. If successful, it should read in the double value in the file and store that, and then return 1, right, for one successful conversion. And then finally, I'm going to read in the string. Right? So %s will read in a string. Notice that the use here of %s is unsafe, right? Because there's nothing here saying how long is the string. Right? It's just %f. So it's going to read everything else in the file until it comes to a new line. Yes, until it comes to a new line. Is that true? I'm pretty sure until it comes to the new line. Right? And it's going to store that in str. Right? So this particular use here is unsafe, but good enough for the time being. Right? And it'll store that in this array up here. Right? Then I'm going to print out the values here. Right? So I'm going to use printf to print the integer, then the floating point value, then the string. Right? val1, val2, and str. So let's see if that works. There's more to the program, but I'll explain what the rest of the program does. So this is fscanf demo. Right, so it says it read one value, read one value, read one value, and the values were 99, 2.5, and hello, which is correct. Right, so that's the contents of the file, 99, 2.5, and hello. Okay. So do you have to do everything one conversion at a time? Right? The answer is no. You can do all the conversions in one shot if you want to. So I'm going to rewind the file. Right? Now when you read a file, it actually reads the contents of the file. Right? So it reads the integer. Right? In other words, it advances forward in the file until it consumes the integer. Right? Then it reads the double, so it moves forward in the file until it consumes the double. Right? And then it reads the string, so it moves forward in the file until it consumes all the string. And now we're at the end of the file. You can go back to the beginning of a file by rewinding it. Right? So rewind f rewinds the file so that you're now at the beginning of the file. So now I can read in the file a second time. Right? So to read in the file again, right, this time reading in all three values at once, I can use fscanf, and this time pass in that formatting string. Right? So %d space %lf space %s. Right? Read in an integer, followed by a double, followed by a string. Right? If you have a space in the formatting string, that consumes all the spaces before the next conversion. Right? So in other words, it will consume everything, all spaces before the double, including the new line character, right? So remember, it reads in an int, right? Then there's a new line, so it leaves the new line. The space here says consume all the spaces before the next double value, right? So it eats the new line, gets rid of it, then reads in the double, right? Eats the new line, and then reads in a string, right? Again, I'm going to store that in val1, but I have to pass a pointer to val1, right? The address of val1, right? I need the address of val2, right? And then I need the address of the first character of my array str, which is just str, right? So n here should be 3. So it should have read in 3 things, right? And if you look at the output of the program, right, it read in 3 values, right? And the values were 99, 2.5, and hello. Right, so you use fscanf to read in formatted data, right? If something happens, so if something goes wrong, then you have to look at the return value, right? So it says it returns 0 if the first token was not successfully converted, right? So it'll return 0 if it can't successfully read in perform the first conversion. It returns this value EOF if the string is empty, or if the string consists only of white space and the current conversion is not %C. Right? So if the contents of the file is all white space and you're trying to read in a string, that doesn't work, right? Or if you're trying to read in a double, that doesn't work. Or if you're trying to read in int, that doesn't work. %C reads in a single character. So if you really do need to read in white space, you have to read it in using %C, right? So consume a single character at a time. That will get you through the last assignment, that one slide. Okay, writing characters. So if you want to write a single character to a file, you can use fputc, right? So fputc writes the character ch to the file stream. Returns the number of written characters on success or EOF on failure, right? And the companion function fputs will read a string. Will write a string to a file, right? So fputs, there's a lot of bugs on these slides, sorry. It's because they're all copy and paste errors. Right? Fputs writes that string to that file, right? Assuming that string is a null terminated string. And it returns the number of, returns a non-negative value on success, right? Or EOF on failure. Finally, if you want to write formatted output, so if I want to write not strings but numbers, like integers or doubles or floating point numbers, then you can use fprintf, right? So fprintf works exactly the same way printf works, except you pass in a file in which to write into. Right? So everything exactly how you use printf, except you pass in a pointer to a file, right? And now it writes into the file. So here's a little example of fprintf. Right? So I open up a file. I'm going to call it formatted.txt. Right? When I open this file, because I'm going to write into it, I have to pass in the W for the mode. Right? So W for write. So I'm going to write to the file f, the string, car, followed by a bunch of spaces and a colon and a space. Right? %C, convert that argument as though it were a car. Right? Followed by the new line. Right. Next line is going to write int, a bunch of spaces, colon, space, %d, right? Interpret that argument as an integer value, right? Followed by a new line. If you want to write an unsigned value, you can use %u, right? If you want to write a long value, it's %ld, right? A double value, oddly enough, you can just use f here. You don't need lf, right? When you scan it, you do need lf. But when you write it, you only need an f. String, %s, right? And just like I showed you with fscanf, you can print out a whole whack of stuff at once, right? So here, it's going to print mix of values, %c, so the character c, right? %d, the number 99, followed by a space, followed by a string, so followed by the string we, right? And then close the file. Right? So if you run that program, you end up with the following output. So this is formatted, right? So you end up with that. Right? So it writes the character that we specified, which was an A. It writes the int specified, the unsigned int that was specified. That's a long value. There's your double value. There's hello. Right? Now the mix of values, so when we printed that out, where'd it go? Right? Mix of values, so it's going to write the C, then the 99, so that's C99 followed by we. Right? What you get here. All right, so when you're writing into a file, there's this notion, reading or writing into a file. There is a notion of the position in the file. Right? So when you open a file, that file has a position. And that points to where the next character will be read or written, read from or written to. Right? So you can think of just a pointer that's moving through a file, and that's the file position. Right? Or you can think of the index into the file. Right? The file position is usually equal to the number of bytes from the beginning of the file. Okay, so when you open up a file, the file position is normally at the beginning, unless you open it in append mode. Right? Every time a character is read or written, the file position advances by 1. Right? Ordinary files allow read or write operations at any position. Right? So you can open up a file, you can read a character, goes to the next position, then you can write a character, goes to the next position, you can read a character, and so on and so forth. Right? So this is called random access. You can actually jump around inside of a file. Right? So I can write into the first position, then I can jump towards the end, right there, jump back, and so on and so forth. Right? If you open up a stream for append access, this is so this is where things change a little bit. Right? Then all writes happen at the end of the file. Right? Because that's what you asked for. Right? When you append to a file, it always writes to the end. So the file position is only relevant for when you're reading from that file. Right? All writes happen at the end. Okay, so you can manipulate the file position with 3 functions. Right? Rewind, which I just showed you. Right? ftell tells you the current file position. fseek moves to a specified file position. Right? So ftell tells you the current file position in a stream. Right? You pass in the stream, and it tells you where are you in that stream. So here's a little file called tell.txt. Right? So it's got 1, 2, 3, 4, 5 characters on each line. Right? There's actually 6, because there's a new line character right here. Right? So A, B, C, D, E, new line. Right? F, G, H, I, J, new line. Right? And so on and so on and so forth. Right? And then there's a T, and then it stops there. So there's actually, does it stop there, or is there another? Oh, sorry. It does stop there. So there's actually 26, 12, 18, and 5. So 23 characters in this file. Right? So that's file position 0. The T is file position 23. Right? And here's a little program that uses ftell to give you the position. Right? So we're going to open up the file. Right? For read access. I'm going to call ftell to get the current file position, so that's POS. Right? I'm going to use fgetC to read in 1 character at a time. Right? So it prints out the current position. Oh, sorry, it prints out the character. C. So it prints out the character that's read by fgetC. Then it prints the position in the file where the character appeared. Right? Right. So it prints out the position where the character appears. Right? And then it calls ftell again to get the next, or to get the current position after reading the character. Right? So this is tell.txt, right? So there it is. Okay. Right? And so when you run tell, it says, well, it reads in the A. Right? So the A is at position 0. Right? So it reads the A, it advances the file position to here. Right? So that's position 1, and that's the B. Right? So when you read the B with fgetC, right, it advances the position to C, right? And so the C is at position 2. Right? Read the C, advance the file position to the D. Right? Output here is weird. Right? So we read the E, and now it says new line, blank space, position equals 5, right? The new line is here because there's a new line right there, right? The new line character is there even though you can't see it. Well, you can see it because the F appears on the next line, right? So this blank line is actually that new line, that new line character right there, right, which is at position 5. Then 6, 7, 8, and so on and so on and so forth, right? And then it stops at the T. T is 22, sorry. And then I guess there is a new line in this file. So there's a new line at position 23. So we know what rewind does, right? So rewind will take you back to the beginning of the file, right? So this program here is the exact same program as before, except when I get to the end, right? So when I get to position 23, I rewind the file to go all the way back to the beginning, right? So what does this do? It just prints out stuff forever, right? So it just keeps going forever, right? Because it just rewinds the file and then prints out the file again, and then rewinds the file, then prints out the file again, and then rewinds the file, right? And so on and so on and so forth, right? Rewind is more useful than you would think. So the assignment tries to, the assignment suggests one way in which you can use rewind in a useful way. Right? Okay, so fseek will move you to a specified position in a file. Right? The syntax is a bit odd. Right? So you specify the file, and then you have to specify these two things. There's this offset and there's this origin. Okay, so. So this says if the stream is open in binary mode. So in Linux, when you open a stream, it's always in binary mode. In Windows, there's a binary mode and a text mode, right? But in Linux, it's always, everything's in binary mode. So if the stream is open in Linux, the new position is exactly that many bytes measured from the beginning of the file if origin is seek set, right? So in other words, if you imagine your file is just a giant array, right? Then if you pass in seek set, offset's just the index of the array that you want, right? From the current file position, if origin is seek cur, right? So the offset is the number of characters to move forward if you pass in seek cur, right? So if that's seek cur and you pass in 1, it goes to the next character, right? You can also, you can seek from the end of the file sometimes, right? So if origin is seek end, then it's the number of bytes from the end. However, the standard says that binary streams are not required to support seek end, right? So in other words, in Linux, seek end may not work. I haven't actually tried on my computer to see if it works or not, right? So seek set from the beginning, seek cur from the current position. All right, so here's our program again. So we're going to use the same file, tel.txt. Right? I've got a little buffer of size 4, and that's going to read in the position to CISC2. Right? Why do I need? Oh, why do I need 4? Here's an interesting question. Right? So the position in the file is going to be between 0 and 23. I know in this file, right? So those are the valid positions in this file. So 23, that's got 2 characters in it, plus the null terminator, so that's 3. Right? But the buffer here is 4. Right? And you might wonder, why do I use 4 and not 3? Right? And so fgets reads in the new line character. Right? So fgets will read in the 2, then the 3, then the new line, and then the null terminator. So you need 4. If you use 3, you get funny output with the program. So I'll change it to 3 in the actual program, and you'll see what happens. Right? Okay, so I'm going to read in something. Right, I'm going to read in the position. I'm going to convert it to an integer value. Right? If the position is negative, we're going to stop the program. Right? We'll break, and then we'll close the file. Right? If the position is between 0 and 23, I'm just going to jump to that position and print the character using fgetc, or get the character and then print it. Right? So this is fseek. No. What's this called? Seek. Okay, so remember we have 23, up to 0 through 23 are valid positions, right? So if I type in 0, right, it found an A at position 0, right? So if I type in 10, it's going to seek from the beginning, right? And it finds the J at position 10, Right? If I type in 23, it finds the new line at position 23. So that's the new line at the end of the file. Right? And if I type in a negative number, it quits, which is nice. Right? If I change that buffer size to 3 and recompile the program, sorry, GCC minus, right, and then rerun it. Okay, enter a position to CISC2. So everything works fine if you use a single digit, right? So the B should be at 1, C should be at 2, D should be at 3. As soon as you type in 2, right, it says, well, I found the J at 10, and then it immediately prints out I found a at 0, right? And so the reason this is happening is because when I type in the 10, my buffer is only length 3, right? So when I type in the 10, I get that, and then I get the new line. Right? And then the way the program is written is it doesn't reset the buffer each time, right? So it reads into the buffer using fgets, right? Comes back around, right? Puts, right? Enter position to CISC2, right? And then it reads the buffer again. Right? But there's something left there, right? The null terminator is sitting right here, right? And so now it gets in the 0, and now it just keeps on going. All right? And then you get that extra line of output, which is very strange if you don't remember that fgets reads in that new line. Okay. Reading and writing to a file. What time is it? Okay. So I guess when I showed you how to open up a file, there were these extra modes, right? The R+, W+, and A+, which we haven't used yet. If you open them up in the plus modes, you are allowed to perform both input and output, right? So I can write something to the file, and I can read something from the file. When you write something to a file, you cannot immediately read something from a file. You have to write, then move using fseek, and then read. Right? Similarly, when you read something from a file, you cannot immediately write to the file. Right? So if I read something in, and then I want to write, I have to call fseek or fsetPosition or rewind. Okay, so this program here is going to replace a specified character, all instances of a specified character in a file. Right? So we're going to open up a file, that one. I'm going to look for a target character. For every instance of the target character, I'm going to replace it with replacement character. Right? So this program is going to read in the file one character at a time. Right? If it finds the target character, right? So remember, when it reads in a character, it goes to the next character. Right? So if I'm replacing the A, I find an A, it's going to go to the next character. I have to back up 1. Right? So if I find the target character, I back up 1. Right? So -1 positions from the current position. Right? And now I can write the replacement character over top of the target character. Right? And you keep on going. So I have a little file here called temp2. Right, it's just I just ran fortune a bunch of times and concatenated everything to a file. Right, so it's just got a bunch of random text in it. So I want to replace, I don't know, what do we replace? We'll replace the E, I guess. So dot replace. So in temp2.text, we're going to replace the E with, I guess we'll replace it with the hashtag. Right. So that runs, and if you look at temp2.text, right, every E has now been replaced with a hashtag. Right. Right? So the only interesting thing here is this called the fseek, right? Read in a character, that causes the position to advance by 1. If I want to overwrite the character I just read in, I have to back up 1 from the current position, right, using fseek. Right? Now, you might think that you can take a file in Unix, right, and then instead of just replacing a single character, I might be able to insert a string or something into the middle of the file. You can't do that. So there's no way to insert a character into the middle of a file or delete a character from a file. Right? So I can't insert into the middle or delete from anywhere. Right? There's no way to, because there is no such thing as the empty character. Right? So in other words, I can't use that same program to replace a character with a string whose length is not 1. Right? So I can't replace every A with the string ABC, for example. Right? Similarly, I can't delete a particular character from the file. Right? The only thing you can do if you want to insert a bunch of stuff is add it to the end. Right? So you can always append to the end of the file, but you can't insert into the middle of the file. Right? So you might think, well, that's silly, right? Because there's you can easily come up with situations where you do want to insert stuff into the middle of the file. Right? If you want to do that in C, what you have to do is one of the two following things. Right? So either you read the entire file into memory, perform the required insertion deletions on however you stored the file in memory, probably in an array, right? And then write the updated text back to the file. Right? Alternatively, you read from the file, right, and write to a second output file in the same loop. Right? So in other words, if I want to replace the A with, say, ABC, all instances of A with ABC, you start reading from the file, right? And then you write, so you get to an A, and then every time you read a character from the file, you echo it into the second file, your second output file. Right? When you get to the character that you want to replace, you write the replacement string to the second file, and so on and so on and so forth. Right? But there's no way for you to edit the contents of a file on disk in C. Right? You're limited to either replacing single characters or appending at the end. All right. Any questions on today's lecture? Yes? The buffer overflow? Here? fseek. Okay, so I want to, if my file looks like A, B, C, right? I want to replace the B, right? So I'm using fgetC to read in a character, right? So the file pointer starts there, right? So it starts at the beginning of the file, right? I call fgetC, that reads in the A and advances the file pointer, right? So now it's at the B, right? I call fgetC again, so that reads in the B, right, and advances the file pointer, right? But now you say, oh, wait, I wanted to replace the B, right? So I have to move the file pointer back 1 position so that I replace the B, right? So I want to move that back 1, and the way you do that is you call fseek, right? You want to seek from the current position, so that's what seek cur means, right? So the current position is here, right? And I want to back up 1 position from the current position. So it moves the file pointer to the B, and now I can overwrite the B. Yeah. Right? It's just an iterator, if you want to think of it that way. Yeah. All right. That's it. I'll see you on Wednesday.